Infinite Science presents the incredible story of Voyager 2, the spacecraft that turned the outer solar system from distant points of light into real worlds. Launched on August 20, 1977, Voyager 2 began one of the greatest exploration missions in human history. It was built with 1970s technology, carried no astronauts, and had less computing power than a modern phone.
Yet this small spacecraft would visit Jupiter, Saturn, Uranus, and Neptune, something no other spacecraft has ever done. Its mission was possible because of a rare planetary alignment that happens only about once every 176 years. Jupiter, Saturn, Uranus, and Neptune were positioned so Voyager 2 could use each planet's gravity to slingshot itself toward the next.
This became known as the Grand Tour. Before Voyager 2, the outer planets were mysterious and remote. Uranus and Neptune were especially unknown, seen from Earth as tiny blue-green dots. Scientists had theories, but no close-up images, no detailed measurements, and no direct understanding of what these distant worlds were really like. Voyager 2 changed everything. Its first major encounter was Jupiter in 1979. As it approached the giant planet, Voyager 2 revealed a violent world of storms, bands, lightning, and swirling clouds. Jupiter's Great Red Spot, a storm larger than Earth, appeared as part of a constantly moving atmosphere filled with turbulence. But the biggest surprises came from Jupiter's moons. Io, once expected to be a cold and cratered moon, turned out to be the most volcanically active world in the solar system. Voyager 2 confirmed huge volcanic eruptions, blasting materials hundreds of kilometers into space. It was the first time active volcanoes had ever been seen beyond Earth. The cause was tidal heating. Jupiter's gravity, combined with the pull of nearby moons, stretches and squeezes Io as it orbits. That flexing creates internal heat, melting rock inside the moon and powering its volcanoes. This discovery changed planetary science forever. It proved that worlds far from the Sun could still be geologically alive. Then there was Europa. Voyager 2 showed Europa as a bright, icy moon covered with long cracks and very few craters. Its smooth, fractured surface suggested that something beneath the ice might be moving. Today, scientists believe Europa may hide a global ocean under its frozen crust, making it one of the most promising places to search for life beyond Earth. Voyager 2 also studied Ganymede, the largest moon in the solar system, and Callisto, an ancient world covered in craters. Together, these moons revealed that moons are not just lifeless rocks. They are complex worlds, each with its own history. After Jupiter, Voyager 2 used gravity to travel towards Saturn. In 1981, it reached the ringed planet and revealed Saturn's rings in extraordinary detail. What looked from Earth like smooth bands became thousands of thin ringlets made of ice and dust. The rings contained gaps, waves, braided patterns, and sharp edges shaped by the gravity of small moons. Voyager 2 showed that Saturn's rings were not static decorations. They were active, dynamic systems controlled by gravity, collisions, and orbital motion. Saturn's moon Titan also became a major focus. Titan is larger than Mercury and has a thick atmosphere rich in nitrogen. Voyager 2 could not see its surface clearly because of its dense orange haze, but the discovery confirmed Titan as one of the most fascinating worlds in the solar system.
Later missions would find lakes and seas of liquid methane and ethane on Titan, but Voyager 2 helped reveal that this moon was not ordinary. It had weather, chemistry, and an atmosphere unlike anything else known at the time. After Saturn, Voyager 2 continued into territory no spacecraft had ever entered. Its next target was Uranus.
In January 1986, Voyager 2 became the first, and still the only, spacecraft to visit Uranus. This distant ice giant was unlike anything scientists had seen. Uranus rotates on its side, tilted about 98 degrees. Instead of spinning upright like most planets, it appears to roll around the Sun. This strange tilt may have been caused by a massive collision early in its history, though scientists still do not know for certain.
Because of this tilt, Uranus has extreme seasons. Each pole can face sunlight for decades, while the other remains in darkness. Voyager 2 found Uranus to be extremely cold, with an atmosphere mostly made of hydrogen and helium, plus methane that gives the planet its blue-green color. At first glance, Uranus looked calm and almost featureless, but its invisible magnetic field was shocking. Voyager 2 discovered that Uranus's magnetic field is tilted and offset from the planet's center. It does not line up neatly with the rotation axis. Instead, it behaves like a strange, lopsided magnetic system, creating one of the most unusual magnetospheres ever observed. Voyager 2 also discovered new moons and studied Uranus's dark, narrow rings. One moon, Miranda, became one of the strangest objects photographed by the mission. Its surface looked broken and rebuilt, with giant cliffs, grooves, canyons, and patchwork terrain. Some features suggested a violent geological past, as if the moon had been torn apart and reassembled. The Uranus flyby lasted only a short time, but it remains the foundation of much of what we know about the planet today. Then came Voyager 2's final planetary encounter, Neptune. By 1989, Voyager 2 was more than 4 billion kilometers from Earth. Sunlight at Neptune is nearly 900 times weaker than on Earth. Many scientists expected a cold, quiet planet. Instead, Voyager 2 found a world of extreme weather. Neptune had the fastest winds ever measured in the solar system, reaching more than 2,000 kilometers per hour. These winds were astonishing because Neptune receives so little sunlight. The discovery suggested that Neptune is powered by internal heat escaping from deep within the planet. Voyager 2 photographed the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. It also saw bright methane clouds casting shadows over lower layers of the atmosphere. Neptune was not still or frozen. It was active, violent, and alive with motion. Then Voyager 2 studied Triton, Neptune's largest moon. Triton turned out to be one of the mission's most amazing discoveries. It orbits Neptune backward, opposite the planet's rotation, suggesting it may have been captured from the Kuiper Belt long ago. Even though Triton is extremely cold, Voyager 2 found signs of activity. It discovered geysers erupting nitrogen gas and dark material above the surface. Triton had very few craters, meaning its surface had been renewed in the recent geological past. This was a shocking discovery. A moon at the edge of the solar system, where sunlight is weak and temperatures are brutal, was still active. With Neptune behind it, Voyager 2 had completed the most ambitious planetary tour ever achieved. It had revealed volcanoes on Io, possible oceans beneath Europa, complex rings around Saturn, a thick atmosphere on Titan, a sideways Uranus with a strange magnetic field, violent winds on Neptune, and geysers on Triton. No spacecraft has ever repeated this journey, but Voyager 2's story did not end with Neptune. After its final planetary flyby, it continued outward toward the boundary of the Sun's influence. The Sun releases a constant stream of charged particles called the solar wind. This creates a massive bubble around the solar system called the heliosphere. The edge of that bubble is called the heliopause. Beyond it is interstellar space. In November 2018, Voyager 2 crossed the heliopause and became the second human-made object to enter interstellar space after Voyager 1. This crossing was especially important because Voyager 2 still had a working plasma instrument. That allowed it to directly measure the density of plasma beyond the Sun's protective bubble, giving scientists rare data from the space between stars. It detected fewer solar particles and more galactic cosmic rays, confirming that it had entered a new region of space. Even now, Voyager 2 continues to send signals back to Earth. Those signals are extremely weak, traveling billions of kilometers before reaching NASA's Deep Space Network. A command sent from Earth takes many hours to reach the spacecraft, and the reply takes many more hours to return. Every signal is a whisper from the edge of human exploration.
Voyager 2 is powered by radioisotope thermoelectric generators, which convert heat from decaying plutonium into electricity. But that power is slowly fading. To keep the spacecraft alive, engineers have turned off instruments and heaters over time. Eventually, Voyager 2 will fall silent, but it will not stop traveling.
It carries the golden record, a message from Earth intended for any distant intelligence that might one day find it. The record contains greetings in many languages, music from different cultures, natural sounds from Earth, and images showing life on our planet. It includes wind, thunder, birds, whales, footsteps, heartbeats, and human voices.
The chance of Voyager 2 ever being found is incredibly small. Space is vast, and the spacecraft is tiny. But the golden record was not created because discovery was likely. It was created because exploration is also an act of hope.
Voyager 2 is more than a machine. It is a time capsule, a memory of Earth, a message from humanity. It tells the universe that a civilization on a small blue planet looked up at the night sky and chose to explore.
Voyager 2 changed our understanding of the solar system. It showed that distant planets are not dull or empty. They are filled with storms, magnetic fields, strange moons, hidden oceans, rings, volcanoes, and frozen worlds that still erupt into space. It proved that the universe becomes more astonishing the closer we look.
And it left us with questions that still drive science today. Could Europa's ocean contain life? Why is Uranus tilted so dramatically? What powers Neptune's extreme winds? How active is Triton today? How far does the sun's influence truly reach?
Voyager 2 did not end the mystery. It expanded it. That is the true power of exploration. Today, Voyager 2 is still moving through interstellar space, carrying Earth's message into the galaxy. Long after its power fades, it will continue drifting through the Milky Way for billions of years.
Silent, frozen, alone, but unforgettable. A spacecraft built by human hands, launched from Earth, sent across the outer planets, and now traveling between the stars. Voyager 2 reminds us that humanity's greatest journeys begin with a simple question: what is out there? And sometimes the answer changes everything. This is Infinite Science, bringing you the greatest stories of space, discovery, and the universe. And Voyager 2 remains one of the greatest stories ever told.